this lecture, we'll talk about image filtering. And this is the outline. First, we'll talk about how we can represent images as a function. And after that, we'll talk about how we can extract useful information from these images. And this will cover a histogram of images, how we can extract edges, how we can smooth noise in the images. We'll cover like two important concepts, convolution and correlation. So these will be used for filtering. And again, these will be used later as well when we talk about convolution neural networks. Then we'll talk about image derivatives, how we can use to extract meaningful information from images. And finally, we will talk about like some basic examples of filtering. Okay, so these are like the chapters from these books. If you want to go into more detail of any of these topics, I will refer you to these books. So let's start with image digitization. Now, in the real world, if we are actually observing something, everything is continuous for us. We can't say that, okay, we are at the first pixel or we are at the second pixel, right? We can't actually divide it. And that's also true for if you think about if you are trying to measure something in real world. Let's say you have a scale. In a scale, it's kind of discrete. You can say that, okay, 1 millimeter, 2 millimeter, 3 millimeter, there is some precision there, right? But if you look at like the objects in your environment, you can go like in as much detail as you can. It's never going to end. So that's kind of continuous space. But as we move on to computers, we'll have to be discrete. We cannot capture these images in a continuous space. So therefore, what we have to do is we have to perform image digitization. And this is basically just transforming this continuous space into discrete space. And this image digitization, it has like two main steps. The first one is called sampling, and the second one is called quantization. So we'll cover these two in detail now. First of all, let's try to understand like this image digitization in a very simple one-dimensional space. For example, we have a function f, which takes as x as input, and it produces y. So it's a very simple one-dimensional function. Okay, so later we will see how we can represent images as function, but let's start with this simple case. If you describe this function in this two-dimensional coordinate space, and let's say this curve represents this function. Okay, so what's happening here is the x over here corresponds to the x-axis, and this is called domain of this function. Domain means like on what values this function will operate. So this function will take values starting from 0, maybe this is 1, 2, 3, 4, right? So this is called domain of the function. And the output of the function, which is represented by y, that's called range of the function. And in this case, the y-axis represents that range. Okay. Now, as I said, image digitization, it has two steps, sampling and quantization. Sampling is discretization of the domain, and quantization refers to discretization of the range.